Hello, my name is Karimi and I want to present our paper. Our paper title is Soccer Video Imitation Using Machine Learning. Other authors are Ramin, Toosi and Dr. Akhaee. Soccer has attracted increasing public attention, turning from a sport activity into an industry with a dramatic turnover. Nowadays, soccer is among the most popular sports, highly welcome worldwide. Given the needs of soccer clubs to research and develop in order to achieve better results in competition. A great body of research is now being carried out on soccer. This includes match analysis, event detection, video summarization, player tracking, ball tracking, and other research areas. An open area of research in soccer is event detection, which is generally conducted using a variety of machine learning methods or recently by employing deep learning methods. Event detection is often used to complement other research fields in soccer analysis, and the analysis of a soccer match needs to detection of events that occurred during the match. Efficient event detection could make outstanding contribution to summarizing a soccer match effectively, or automatic referring requires the detection of events such as foul, tackles, and offsides. Uh, Many research are published in recent years. You and others is among the first work done in the area of event detection in a soccer match, which employed detection and tracking of the goal, player, and the ball to generate higher level information. In Hossein and other papers, a fuzzy role-based system is employed to create a flexible system to detect events without the need for a series of predefined feature sequence or domain knowledge derivative structures. In Zhang and other papers, an event detection approach was proposed by combining a CNN and RNN. First, they created a video dataset and then trained it with a CNN. They eventually evaluated the applied method in 13 soccer match. In Mo and other papers, proposed an algorithm that extracts keyframes by applying the self-attention mechanism algorithm, and then extract a time video level of event in soccer match. The method presented in Mahasani and other papers employ modified two-stream networks for each frame to extract spatio-temporal features. In this study, a dataset consists of 8,000 soccer match clips collected in 8 categories. The superiority of the collected dataset in this paper over datasets such as SoccerNet V2 and SoccerNet V2 lies in the diversity of data available in this dataset. The video of the collected event in this paper are not related to similar match. They are collected from various matches. In other words, each video comes from a unique match, and this has led to increased diversity in this dataset, and like as a stadium, teams, and grandstand in the dataset. The collected dataset consists of 8 events: corner kick, card, substitution, free kick, penalty kick, goal, foul, no highlight. The total length of this dataset is 12 hours. Figure shows a sample collected dataset. This dataset will be referred as the soccer event in this paper. We name it this soccer event. The method present is a method based on CMS neural network. CMS neural network are networks that use a different solution to use them depending on the similarity of the inputs. This can be done by two CNN with predefined parameters. The difference between which is used to determine the similarity of two images. This is exactly what the CMS network does. This input include image, numeric data, sentence, and so on, and we use CMS neural network to implement the method. The first stage is data preparing. The data must first be ready to use. We have three types of data: anchor or main video, positive, or a video from main video, negative, or a video from other categories. The SoccerNet dataset and SoccerNet V1 are prepared accordingly for use and dataset in train of networks. The architecture used in our network is the efficient 2B0 network-based architecture, and it combines with GRU layer, the input of which will be video frames, and that will be given frame by frame to create network. Then the frames will be embedded and feed to GRU layer when they are modeled, and the output of network will be 512 vector used to compare two videos. You can see a view of the architecture in this figure. We use contrastive loss in CMS network as following equation. In this equation, we have three parameters: x1 and x2 are input images, and y is about similarity, and y is 0. Inputs are similar, and when y is 1, inputs are not similar. First, we test a different CNN architecture for backbone network and viewed it stable. Efficient 2B0 have the best accuracy in comparison to other CNNs with light networks. Then this network could achieve 64.9% mean average percentage on SoccerNet V1 and 93.76% mean average precision on soccer event dataset, efficient 2B0. Many types of recurrent neural networks were introduced, such as LSTM and GRU. Here we compare four architecture, and results show that GRU is the best architecture for our purpose, achieving 93.70 mean average precision on soccer event dataset. Result of comparison of type of neural network shown in this table. Feature vectors are used to comparison between to the samples, one as a reference and one image as the new instance that should be categorized. So length of the feature vector is important for the performance, for the accuracy. In this experiment, the effect of the length of feature vectors, output vectors or feature vectors on the performance of the proposed method is investigated as shown in this table. The best accuracy with percentage 93.78 mean average precision was obtained when the number of features of our network output was equal 1024. Of course, has a small percentage difference with the time when the number of network output features equal to 512. Consider that reduce the number of features decreases the calculation time of the distance between features. Finally, we chose the number of features of 512. Many loss function has been introduced for CMS networks and to investigate the effect of use loss function on the performance of the proposed method. In this experiment, the proposed architecture is trained with three loss functions: triplet, streaker, and contrastive loss. Results show the contrastive loss is better than other loss function for our problem. As shown in this table, our proposed method has better accuracy than other method in two different datasets, SoccerNet V1 and SoccerNet soccer event dataset or our dataset. Our proposed method has been able to record better accuracy than similar method. Our method is 64.9 percentage accuracy in SoccerNet V1 and 93.76 percentage on soccer event accuracy. Sorry, or map. I mean average precision on soccer event and in average precision in SoccerNet. And MLSNE or efficient to Excel has lower mean average precision from our method. And finally, I want to conclude this presentation. In this paper, an architecture based on the CNN GRU structure was proposed in a comparison between the LSTM RNN and GRU. As the recursive network in the CNN RNN structure, better results were achieved by GRU as expected. Consider short length sequence for more. Our proposed method use metric learning, which hadn't been used in this event detection of soccer video. We compared the various match structure, loss function, and output lengths to find the best parameter for final methods. Thanks method. This is the first attempt of using metric learning in soccer videos. This showed that we could use metric learning in player tracking, video summarization, and other imitation text tasks and soccer match analysis. Thanks for your attention.